Bismillahirrahmanirrahim. Today I want to present my waste and in Israel, the province in Saudi Arabia. I am Marwan Amin Dawood and my structure is Dr. Light Al Hadid. Today I will start about abstracts. Saudi Arabia generates a huge quantity construction and precast waste. This research aims to investigate precast in the eastern province of the Saudi Arabia to determine the most critical factors as effective in precast waste in eastern province and studying the strategies and policies to reduce the waste generation and current cost in precast factories. Precast waste factors identified from literature were evaluated by experts and obtained 40 factors and ranked by using relative importance index method. The waste factor is categorized in 7 main groups. Each group has sub-main factors. The total group is, first of all, management, machinery and equipment groups, design group, methodology group, moving and transportation, material and manpower groups. It's shown from these groups that 30% of the generated waste could be eliminated if corrective plan is effectively applied to these effective factor or causes factors. So while recycle, aggregate, and reuse could be reduced about the waste about 40 and 12% respectively from the total generated waste in precast factories. On the other hand, crusher machine has the main contributor of the cost reduction. It reduces recycled concrete aggregate and it saves about $7 per cubic meter, about 70% from original aggregate price. The next one, washing aggregate machine, that is which has been used in most of the precast factory. That washing costs about $1.3 per cubic meter. By using this way, to increase compressive strength, that is make the improvement for the quality for the concrete. That's increase the compressive strength about 24%. That lead us to reduce 35 cement kg, saving about 5.5% from a total cost for each cubic meter. Outline for my presentation is first introduction, second literature review, third research methodology, number for discussion of the collected data, conclusion and recommendations. Back introduction, we start for the backgrounds. Due to this improvement and expansion in precast field, a lot of the waste had been generated about 75,000 tons per year in eastern province of the Saudi Arabia. The majority of the waste in the construction is made up of the concrete. The huge quantity of the concrete waste has been coming from lack of effective management for this wastage for the disposal and recycling. In eastern province of the Saudi Arabia, all construction field generated waste about 1 million tons from total waste at landfill that coming from construction and precast factory both to the landfill area. From this percentage, this about 7.5% from total generated waste, about 75,000 tons just generated from precast factory. Most precast factories has an acceptance percentage of the waste about range from 2 to 4%. Unfortunately, all precast factory has waste range vary from 7 to 11%. This is a huge difference that make us to focus about solution to reduce to mitigate this a huge percentage of the waste. So the acceptance about from 2 to 4, but our existing case in all precast factory, the average is very about from 7 to the 11%. This is the picture that shown one in precast factory that a huge amount of the concrete waste just in one precast factory, and all of the factories like this quantity wastage in their factories. I will start now for a statement of the problems. 1. Lack of attention about extra cost, waste, and environmental effect. Secondly, no strategic management plan applying precast factory to mitigate this quantity. Objective of the study. The main objective of the report is 1. Determine the causes of the precast factory. Provide and suggest an effective strategy and a plan to present a proper solution to those affected factors. Number 3. Evaluate the environmental and social role in waste management. To allocate effective 3R principles and procedures that mitigate wastage costs in the precast. Number 5. Propose the ways of the maximization of profit increment related to the production improvement. Reduce unnecessary. Now, the significance of this study. First of all, reduce unnecessary costs and improve concrete quality and productivity. Secondly, providing management plan with a selection tool. Number 3, first study is conducted in eastern province of Saudi Arabia. Scope and limits for this study. First of all, this study is concerned and limited in precast factory in eastern province area just for the 10 precast factories. That is all of the factories. That is the main factories available in eastern province in the Dammam and Khobar. Number 2, other construction field is not considered, such as highway field, such as building field, is not considered. Just our study for the precast factory only. Number 3, the condition of collecting data is gathered or assumed for limited number of specialists and experts in precast fields. Number 5, a small factory is not considered in this study. Literature review. We are talking about recycling concrete aggregate, examination, the concept of the waste, and the classification of waste. Basic concept of the waste. There are several definitions for the waste. First, of that is an extra and unnecessary materials balance after product completed. Number 2, an extra earth material need to use in construction that could transfer, landfill, reuse, and recycle as a construction waste. Classification of the waste, we have this the criteria, and we have example for the waste, such as source of the generation waste coming from highway, building, infrastructure, the project material, such as solid, liquid, and gas. Level of the risk, hazard, and non-hazard, just that is in the general. We are going for the pilot study. The main objective of this pilot study is to investigate the research protocol and the tools of the data collection to establish actual case study. First, a pilot study had done by visiting and evaluating 10 precast factory in this area. Second, pilot study is done through 10 engineers more than 15 years of experience. Research design. Step 1, determine the topic name and this objective. Step 2, pilot questionnaire to collect the beneficial information about this study. Number 3, cluster all information required and specify the objective. Step 4, finalize the objective. Step 5, write the questionnaire, code it and finalize the questionnaire and analyze the information from a questionnaire. Number 7, ranking all factors support from questionnaire results. Number 8, select the main factor from each 7 AMI groups categories and determine the main weakness point that causes excess wastage in the factories to suggest the proper solution. Number 9, selecting a proper waste material from actual product. Make actual experiments. Number 10, listed all waste experiment results and previous results and compare the results in a comparison sheet before and after experiment. Number 11, study actual case of waste aggregate system and discuss briefly the results before and after experiment also. Selection of the case study. The study covered 10 case studies of precast concrete factories at Eastern Province, the second industrial area of Dammam and Khobar. The tools obtained in this study are site observation and personal interview with the factory and production manager of precast concrete factories. Let's see the list of the list of our factories. We are talking about the 10 factories, starting from idle precast factory to Alabnia factory, all shown in these tables. And the the manager, we are talking about 10 managers, experts from precast factory. Their experience vary from 15 to 22 to 25 years. Now we are going to another chapter, which that chapter is factor causes and waste in precast factories. Construction and precast waste are considered one of an important topic in construction field. Research and studies done in Saudi Arabia on this topic, especially in Eastern European zone. These factors were identified by questionnaires, literature, and previous research. This summarized and analyzed by pilot studies. The result shows that the following factors are ranked highly significant as one. Following safety rules. Second, control and supervision. Third factor, main factor causes, is periodic equipment maintenance, designer experience, poor quality of raw materials, unskilled workers, damage during delivery. The methodology of this for the analyzing the factors. Step 1, we are talking about literature review. We are going in depth in the review for that. The output of that, identify preliminary factors. Step number 2, make pilot study. The output is obtain list of final factors. Step number 3, questionnaire survey. The output is quantitative and evaluate responses. Step number 4, ranking factors, prioritize factors. Step number 5, factor analysis, explain potential factors. Pilot study. This study was done through 3 managers of precast factory in the man with more than 25 years of experience. The first expert eliminated 12 factors from all factors provided from 6 studies. The second expert eliminated 10 factors from all provided factors. Third expert highlighted his point to another field. He suggested to include safety field as the following safety rules. Analysis techniques, we are going for relative important index. This equation is known for everybody how to calculate RII, relative important index. I think it's very clear for the all. Now we are going to identify the main factors which they are causes waste in precast factories. So first factor is following safety rules that has been ranked about 0.894. Take rank number 1. Factor which has been ranked number 2 in management group, that is control and supervision. It takes about 0.824. Number 3, periodic equipments take about 0.8. Number 4, batch plant calibration takes about 0.79. Ranking group for the categories factories. Here we are going for the 7 groups: factory, machinery and equipment, management, manpower, method, and the last moving and the transportation. So first one is the design group, take about 0.658. It take high level, and the least one that is going for the moving and transportation, which has been ranked 0.4. It's going from medium to low level. So here we are going to make a good representation by fishbone diagram. Fishbone diagram is making illustrate each groups. Under each, the main group sub-factors which that causes the waste in the precast factory. As we know, we are going for the yellow one for the design. So it included the factors which cause the waste from the design group, is the design experience, also frequently design change, design mistakes, delay revision, complicated design. And the same for the management group, method group, moving groups, and manpower group, machinery groups. All of these is very clear, and all of these is a factor that is causes the waste, which that's shown in the red color here. After we identified the main causes which has been affected to generate waste in the precast factory, and now we will make the solution how to mitigate this waste from these factors, from the main factors. We identify the main factors, and we are put the preventive action for each factors Also, in the last, we see the result. If we make correction action for the main factor, what's the results? Already I sit with the 3 experts in Precast factories, and we evaluate how much if we are apply solution for this factor, how much it could be mitigated from the main waste in the factory. As an example, we are going for the design. The main factors which causes waste in the design group is design experience. We are making preventive action, which that we same like appointed qualified designer experience in field and office, integrated coordination between practical casting and design, review all design drawing with other designer office before issue. If we apply this preventive action, it could be save about 5% from total waste in the precast factories. Number 2, we are going for the machinery equipments. The main factor is periodic maintenance. Preventive action should be allocated, specialized, and qualified to maintain and repair all equipment in the factory. If we apply it, it will be reduced 9% from this. Management, control, and supervision assign a good and dedication supervisor. If we apply it, it will be reduced about 4%. The next one also for the following safety, we have to make preventive action, provide effective safety program to all companies employees, evaluate any person who is not following instructions, and incentive and encouraged by bonuses for the commitment workers. It will be save about 7%. From the last one material group, it will be save about 1% if we apply our strategy for the corrective plan. This fishbone diagram we are making for the main groups for the design, what we will make, the corrective plan, integrated coordination between practical casting, and review all the design drawing with the other designer office before and after issue, appointed qualified and designer experience. Same for the other main groups all. That is very clear, very shown for the readers. These all factors, if that apply by fishbone diagram, it should be minimize the waste. We are going now for practical application from our study. So, reduction cost is one of the main study objectives. Our study concerned on 2 practical issues to achieve this goal. First of all, install a crusher machine, aggregate machine to recycle and reuse recycle aggregate. Establish aggregate washing machine to improve quality and reduce product cost. Experiment program. An experiment study of recycle aggregate concrete is applied by using recycle aggregate. First of all, we are taking 100% from natural aggregate and we are making the test and we are see the result for that. Then we are going to make 100% from recycled concrete aggregate, which that is crushed and recycled, and we are putting in the to produce a new concrete from that. And we are comparing the both from the quality and the cost, how much if we are using recycled concrete aggregate, it could be work with the same quality as the normal aggregate or not. If it could be applicable and give good the results, we will see how much we are saving cost. We will see in the next slide. Here the recycling our the process we are show as circle. It will be start from crushing waste to sorting, recycle, ready mix, and the structural. That is also is very clear and shown for the reader. This picture that shown the crushed aggregate from precast materials, waste materials. Now we are going for the testing of the concrete compressive strength. As we know, concrete, we are going to take concrete cylinder. Specific test was made with 100% recycled aggregate concrete and be tested, and we will see how much the result comes for the compressive strength. From other hand, also we are using 2 categories from water cement ratio. We are going for the 0.42, that is the normal which that has been used in the normal aggregate concrete use, and we are using for the recycled aggregate concrete, and we see the results. Also, after we are using in the same result for the water cement ratio, we will see how much the result is the difference if we reduce it also, because that is it will be make the optimal solution for our study. Here we are going for this table that shows the compressive strength. Here, if we are using the normal concrete with water cement ratio 0.42, and if we are using recycled aggregate concrete with the water cement ratio 0.4, this compressive strength 44.5 MPa. This here in the same 39.8. So the difference about 88% between the both. So we are make little modification. We add just 10 kg from the cement for this quantity to be, and we are using same recycled aggregate concrete. The water cement ratio will be 0.35. So the result 41.7 is very close, very close and accepted for the normal concrete results. So if we are using the aggregate concrete, normal aggregate the concrete, and if we are using recycled aggregate the concrete, just adding 10 kg from the cement for that, we are achieved for the same the result, nearly same the results with the compressive strength. So that is, if we are using recycled aggregate concrete, it will be applicable to use in the structural concrete. And this the main result from us. So now we are going to calculate the cost if we are applied this way. If we apply it this way, we need to make a crusher to crush all the aggregate or the wastage which are coming from precast factories or from construction sites, to see how much we are saving from this way. So if we are using the crusher machine cost, we have this list breakdown, which does include owning costs, operating costs, everything that is detailed in these tables. In the final result, the total cost about $105,000 per year. Also, we are calculate here, we want to calculate the unit cost. We have the machinery, the productivity 35 cubic meter per hour, and efficiency we assume 0.85, and we have the total cost. Then we can get for the unit cost is $2.7 per cubic meter, just cost for make recycling it from the waste. That is very good results and very cheap results. If we are comparing, if we want to take our waste from our factory and transfer for the landfill, it costs us about $4 per cubic meter. But if we are make recycle, it costs us just $2.7 per cubic meter. That is from one way. And other way, this the recycle aggregate, we can reuse it again to produce a new concrete. Also, the save too much. Also, it can be sold for the other highway projects and road projects. This both benefit, we can get it from practical application for the crusher machine. This is the results here. We are calculating every cost, labor cost, and the loader and equipments. And here, if after the produce the recycled aggregate the concrete, which that costs us $2.7 per cubic meter, compare it with the normal aggregate concrete price is $10 per cubic meter. So the net saved about $7.3 just for just about 73%. Just we are saving from normal aggregate concrete. It's a huge save, good save. Also, good save from both from the price of the materials. Also, we are saving the landfilling. We don't need too much landfill. That is very good. The result, as we know. This is the picture for the crusher machine, how to fix it, and in general we are seeing. Reduce cost. Also, we have another practical application is using washed aggregate in precast concrete. Washing aggregate machine is proposed to be established in all precast factory. The reason of this achieve high concrete quality and reduction cost. As we know, the main factors which has effect about the compressive strength on the concrete is the dust or fine materials from the aggregate. So when the aggregate has fine materials, That is, it reduces the compressive strength because it's absorption too much water. If we remove this fine material from this aggregate, automatically the compressive strength will be high. If the strength will be high, so more than the requirements, then we can reduce the value of the strength by reducing the quantity of the cement, which that save us a lot of money in this way. We are see here. We are making the tests for the aggregate before unwashed aggregate. That is the test on 28 days coming 41 MBA. After we are making the washing for the aggregate washing machine, we got the result 51 MBA, about 24% saving. See, then the requirement need 40 MBA. And after we make washing, just washing for that, we got 51 MBA, so that we have a lot of the amount of the saving. So we can reduce the quantity of the cement. If we reduce the quantity of the cement about 35 kg per cubic meter, we will see how much the result will become. Here, the original one, for the unwashed, we need cement 390 kg cement to achieve 41 MBA from compressive strength. After we are washing and we reduce the quantity of the cement from 390 to 355 kg, we achieve the result 43 MBA, more than the original also. It's very close. And we are saving about 35 kg. This saving, it will become for us just from little washing. And we will calculate how much the cost of the washing, and we will see how much we are saving from this way. Here the picture that we shown, all the aggregate washing machines. Here we are calculating if we are applied the bring washing aggregate machine and we are install it and we are fixing, we calculate everything, capital cost, owning cost, and operation cost, and everything. The total cost is about $22,000 per year. So we have to calculate unit costs. We have the machinery, the productivity, and the efficiency, and total cost we have. So that unit cost will be just $1.3 per cubic meter. So if we paid $1.3 per cubic meter, we are saving about 35 kg from the cement, which that costs about $16 or $17. So this amount, we have number of the saved. If you see percentage of the saved, we have saved amount of the total cost. So per a cubic meter, we have, that is, so per a cubic meter, we are saving about, per a cubic meter, we are saving about $4.75. After we deduct the cost for the washing aggregate machine, which that is 1.3, we receive the net saved about 3.45. So we are saving $3.45 per cubic meter if we add just this way. And also we have the total cost for the cubic meter from aggregate, from sand, from everything is $62 per cubic meter. So we are saving about 5.5% from the total material cost per cubic meter of the concrete. I make one example, illustrative example. I am going to one factories and I see how much the production yearly from 2015 to 2019. And we are saving per cubic meter 3.45. So in this year, 2015, we are saving $78,625. 2016, $83,000. 2019, we are saving $87,802. Big amount of saving from small thing just. So we are going for the benefits of gain in concrete recycling, conserving landfill space and reduction the need for new landfill. Number two, saving natural materials, reducing project costs by using recycled materials. Number four, reducing the cost of transportation from sites and to landfill and tipping fees. Number six, increasing overall business competitive and strategic business opportunities. Number seven, product local resource reduces truck traffic. So we are going for the conclusion and recommendations from our conclusion. First of all, applying 3R method, reduce, recycle, and reuse. Give a high positive result as it reduces about 80% of total waste. Waste factor was reviewed and ranked by using relative importance index method. Those factors are categorized in 7 groups, main groups, one designer experience in design group, and machinery group, manpower group, methodology, and rank about 0.56. In the last one, it has moving and material group, which has been ranked about 0.465 and 0.4 respectively. Factor solution, if we are making the solution for the factor that causes the waste by applying corrective action for that, it reduces about 30% of total cost. If we are going for the recycle aggregate concrete, we are saving about recycle the concrete. We are saving about 40% from total cost using recycled aggregate concrete rather than natural aggregate in structural concrete. It gives about 90% from normal aggregate concrete if we are using. It's acceptable and very close to the original value. When we are using, we have to use 0.35. Water symmetry shows the optimal value to increase the strength from 90% to 100% of using normal aggregate concrete. Precast waste recycling that costs about $2.7 per cubic meters is less expensive than landfill cost, which should be go about $4 per cubic meter, and thus save land areas and natural resources. Construction machine hits the heart of the beneficial economic in construction fields. It reduces about the majority of waste, about 40% of total waste in precast waste. It reduces recycled aggregate concrete with $2.7 per cubic meter cheaper than normal aggregate, which it has been about $10 per cubic meter. That save about 70% from natural aggregate costs. Wash aggregate has a great positive impact on quality to increase compressive concrete strength about 24% compared with unwashed. Applying cost management plan by reducing cement about 35 kg per cubic meter to eliminate unnecessary strength is save around $3.45 per cubic meter, about $5.5 of total cost per concrete. Also, this our summary. If we are using 3R principles, reduce, recycle, reuse. Reduce is the make. It could be done, but the waste management plan for the causes factors. Make corrective action for these factors. It mitigate about 30% from the waste. Recycle. It go for install crusher machine. By producing recycled concrete, it mitigate about 40% from total waste. By reuse, it should be reused the fine aggregate from this one. By saving this aggregate, the waste aggregate, and reuse it in the as base course and subgrade in the roadway projects, it save about 10% from total waste in precast factories. So the total saves 10 plus 40 plus 30%. We are saving 80% from total waste generated in the precast factory. That is very good results. If we are saving 80% and we are saving money for this one. Recommendation to reduce the cost amount in precast factory. Two effective scenarios have been adopted by using wash aggregate in an installed crusher machine to produce recycle aggregate. Number two, applied waste management plan strategy to reduce cost is up to 30%. We are using the water symmetry ratio 0.35 is the optimum value to obtain maximum compressive concrete strength. Compressive and accurate evaluation of concrete recycling. identify and classify various uses of recycled waste, providing in-house training on concrete recycling, high landfill charges for the disposing concrete waste, government financial support for the companies, appointed a qualified designer experience in field and office, calibrate all batch plant and devices at certain time, evaluate any person who is not following instructions, controlling and monitor workers, distributing the responsibility to each level. Thank you very much. I will be thankful for everybody who helped me in this the reports. Also, I thank my doctors, my supervisor, Dr. Lait Al Hadidi, and everyone who is sharing me and helped me for to finish and finalize of my study. Thank you for everyone. Thank you very much.